Hello, my name is Jim Wirtz. I'm the president of Microcosm, and I'd like to tell you a bit about composite propellant tanks for kerosene and liquid oxygen that we're building for the Scorpius family of low-cost, responsive launch vehicles. As you can see from this half-scale model of Sprite, the smallest of the orbital vehicles, the Scorpius design is relatively short and squat. The business end of a Sprite pod is exceptionally simple. It has no turbopumps and very few moving parts at all. But back to the subject of composite tanks. This is a 10-inch test tank. Aaron, Shama, and Lynn in the back are holding a 25-inch tank. Launch vehicle tanks are famous for being thin-skinned and delicate, the prima donnas of the aerospace world, so to speak. They buckle easily, and some have to be continuously pressurized to keep from collapsing under their own weight. Microcosm's propellant tanks for the Scorpius family of low-cost, responsive launch vehicles are built to withstand 550 psi operating pressure and to stand up to external pressure as well. In this case, roughly 4,000 pounds on two of our full-size liquid oxygen tanks for the Sprite mini lift-to-orbit vehicle. The tanks are empty, unpressurized, and have no external support. At this point, I'd be inclined to make a flippant remark about how I would like to see other rocket companies try this, but I really wouldn't. Many of those in this business are friends of ours, and building launch vehicles is difficult enough as it is. What does this have to do with real launch vehicles? It's kind of a cute stunt, but let's face it, launch vehicles with the pointy end up and lifting off the ground aren't going to have a pickup truck hanging on the side. Does this demonstration really mean anything for low-cost, responsive launch? Yep, it really does. In the real world, things go wrong from time to time. Stuff bumps into your tank or launch vehicle. Tanks are most easily stored, unpressurized, and even occasionally get a higher pressure outside than inside. In the jargon of the aerospace world, having a flimsy tank is one more failure mode, something that can go wrong and have the launch scrubbed or the mission failed. Ruggedness cuts costs and reduces failures. But wait, as they say in the commercials, there's more. Weather, particularly high winds, is always a problem for launch vehicles. Many launches are scrubbed due to winds aloft. This delays getting our satellites to orbit, and of course every time we fuel and unfuel a rocket and make and remake all of the launch preparations, that just adds to the cost of launch operations that sooner or later the satellite user gets to pay for. Because of the Scorpius vehicle's short and squat design, and particularly the very robust tanks, Scorpius can fly through 99.9% of winds aloft. We could lift off at over 100-knot ground winds. Of course, no self-respecting launch site will allow operators to be out and about in a Category 3 hurricane, but our vehicle doesn't mind. Some launch vehicles try to get around weather quite literally by launching from an airplane. They'll go where the weather is clear. Unfortunately, that still doesn't get away from the problem of winds aloft, and of course, it means flying the satellite around in an airplane for a while. Well, there are other reasons for launching from an airplane. If our goal is to get satellites somewhere in a hurry, that's not a good answer. For every minute a satellite spends in an airplane speeding toward its destination, it falls 270 miles further behind a comparable satellite in orbit and on its way. The Scorpius tank is also pretty light. Lynn and Shama can pick it up once we've removed the pickup Aaron and me. Even though we've given Lynn a platform to stand on, she still has to stand on tiptoes to lift it. Lastly, there's the small matter of cost. Graphite composite tanks like the ones you've seen here can be built in about a week on a low-cost winding machine and cost about 10% of what comparable metal tanks cost. Lightweight, strong composite tanks are one of the key components of both responsive launch and reducing the cost of access to space. Microcosm engineers not only stand behind our tanks, we stand on them. Thanks for listening.